Machine learning has a bad rap, I think. You know what I'm saying? Like some of the worst things that humanity has ever thought of when it comes to AI, really, have been really destructive. And I feel like when we talk about AI, we need to be careful, right? So I'm going to talk a little bit about what it is. It's basically exploiting patterns in data. Statisticians are kind of mad, because it's machine learning now, and you make more money if you call it machine learning. But if you're a statistician, they're like, wait, what about me? Right? This is what, it's instead of writing code, we give humans giving data. And it's pretty interesting, right? Because you have to answer a sharp question. Because every once in a while, people even in my group where I work at, they're like, hey, can you just make an AI to do this? To do what? You ever, all the data scientists, the marketing dude is like, Bill, he comes in, he's like, can you just make an AI to do this? And you're like, Bill, what are you talking about? Because you actually have to have a very sharp question to actually start with machine learning. You can't just be like, we'll just have AI do it. And these are 5 examples of good questions. Now, I'm not including reinforcement learning. I'm just doing unsupervised and supervised. But how much, how many? Which class does it belong to? Are there different groups? Which does it belong to? Is it weird? And which option should I choose? And these are, once you look at these questions, when you're looking at this, it falls neatly into these 2 buckets called supervised learning and unsupervised learning. And basically, this is the beginning of how I understand machine learning, right? This is regression. This is classification. So when you're looking at a classifier, it's basically trying to guess which class things are in. Clustering is grouping, anomaly detection, and recommendation. And there's a ton of algorithms that do all of these things, but basically, if you don't start with a question, there's really not much you can do, right? And so that's the important bit. So for programmers, generally, and I'm gonna focus on supervised learning for this one, if that's okay. Unsupervised learning, he said I only had 5 minutes, so. So for programming, generally the way we think about things is we have a problem, and we come up with a series of steps to solve it, right? And we make an algorithm, we get the input, and then the answer comes out. With machine learning, specifically supervised learning, we flip those around. Yeah? So instead of actually thinking of a series of steps, you give the computer answers and input, and it will figure out what to do. But you have to give it some idea of how to start. Use this algorithm to come up with a thing. For example, many of you have written code where you've had to change a 0.5 to a 0.7 to make it work that week, and you go home and you take a shower for a really long time because you feel dirty. I'm trying to be explicit here. Or after a couple of weeks, you have to add another if statement, and you go home and you take another long shower because that's dirty. You shouldn't do that. When you do stuff like that in your code, this is a really good opportunity to use machine learning. For example, decision trees are basically glorified if-else statements that are mathematically produced, right? Which is really nice, right? Okay, so basically this is data and this is called a model. So if you're a programmer, I like to think of model as an algorithm, right, that you deploy out somehow. That's how I think about it. And if any of you think I'm saying this wrong, come and tell me and I will fix my slides for next time. All right, so the question is what really goes on in there. There's a process. And now I've simplified it. There's probably more steps. But basically, whenever you have your question, then you need to see, do I have any data to answer that? And if you have no data, then you can't do it, right? It's not magic, it's science, right? Once you have your data, then you need to explore, analyze, and encode your data. Basically, you have to change everything into a number. It's really easy to do that with pictures because the numbers are built in. But how do you do that with text or with speech or with other things? You have to do something to turn it into that. So let's go through this process. Oh, then you make a model, and then you do prediction with that. Let me go through this a little bit slower so you see where the painfulness is. So let's pretend you own a tennis shop, and you want to hire someone extra when more people come, and you have this. And for those of you that have gone through the data science training, this is the tennis data set. So little Billy needs to come in when there's more people, and you want to make an algorithm to do that. Well, it turns out that if your data was like this, that's glorious, but it's actually more crazier than that. And so what you got to do is you got to decide, 30 seconds. Labels are the things that you're trying to predict. Features are the things you use to predict it, but your data actually kind of looks like this. And that's where I'm going to leave it, because basically this is the sadness part of data science. This is a total downer. We all spend like 80 to 90% of our jobs crying under the table because Bill doesn't understand that this is not what we want inside of our weather report. Bill? Like, what do you mean it's kind of windy, Bill? So let everyone sitting there laughing and crying at the same time, right? Once you do this, you clean it up. It's the yak shaving bit of data science. We convert it to numbers, and then you make a model. This is the fun bit. We like this part. Although it never works the first time, and if it does, as you saw yesterday, something's really wrong. Okay? How do you know how well it's doing? We had a really good talk on this yesterday. You separate your data to train it, and another one to test it. Sometimes you even separate it this way, and then you have the confusion matrix, which is a good name for this. That's all.